This is the video introduction for Activity 3.7, Quadratic Function Applications. In this activity, we'll explore real-world problem-solving skills, set up equations, and apply problem-solving to quadratic functions and analyze the result. For this activity, you'll need a graphing calculator. Let's start by talking about maximum and minimum values for quadratic functions. In Homework 3.3, we learned about concave up and concave down. When we work with a quadratic function of the form ax squared plus bx plus c, when a is greater than 0, the graph of the quadratic function is concave up, that's opening up. And when a is less than 0, the graph of the quadratic function is concave down, that's opening down. For problem solving, these graphical components and connections are useful because the low point on the parabola or on any graph is a minimum output value, and the high point on a parabola or on any graph is a maximum output value. Additionally, careful graphing over specific intervals can yield additional high and low points on a particular graph. Let's look at some examples. For symbolic examples without a problem-solving context, we'll just look at these two functions, f of x and g of x, both quadratics. And they're both graphed over the interval 0 is less than or equal to x is less than or equal to 4. By evaluating the function graphs, we can see a variety of maximum and minimum values. Here's our picture. F of x is the concave up graph, and g of x is the concave down graph. The value of f of 0 is greater than the value of the other point near x equals 0. So f of 0 is a local maximum value on f of x over this interval 0 to 4. You can see that we have that marked here. On the graph of f of x, this concave up parabola, f of 0 is higher than all the other nearby points. It's a local maximum. Still thinking about f of x, the value of f of 4 is greater than the value of the other points on the graph, the nearby points and all of the points from 0 to 4. So f of 4 is a local maximum, but it's also a global maximum on this interval because it's the highest of all the high points. The turning point for f of x is 1, 3. Because f of x is concave up, the value of f of 1 is less than the function value of all the other points on the graph of f of x, on this interval 0 to 4, and in fact on any interval. So f of 1 is a local and global minimum value. It's smaller than all the other points on f of x, on this interval, and in fact on any interval. Now let's look at g of x. The values of g of 0 and g of 4 are both less than the value of all the other points on the graph, and they are the same. So g of 0 and g of 4 are both local and global minimums of g of x over the interval 0 to 4. So you can see they're at the same height, and they're lower locally and globally than the other points on g of x. The turning point for g of x is 2, 5. Because g of x is concave down, the value of g of 2 is greater than the function value of all the other points on the graph of g of x on the interval 0 to 4, and in fact on any interval. So g of 2 is a local and global maximum value of g of x. In context, each of these function values and locations might be used to answer questions such as, for what x value is f of x the smallest, or what is the greatest value of g of x? You'll get lots of practice, and in each case, always look at the graph. The graph really helps you tell where the high and low points are.